Welcome to I2C Chip. This short video is to help you try and get the Austria Microsystems AS5011 magnetic sensing going with the I2C to PC adapter or the BL233 controller chip. The AS5011 bills itself as an I2C interface chip, but it doesn't follow the I2C format. In this timing diagram from a datasheet, we can see that it follows the conventional I2C process of writing a start instruction, writing out the device address, writing the register address, but at this point a conventional I2C chip would send another start followed by the device address and then read the data. The Austria Microsystems AS5011 simply continues clocking the I2C bus and it reads the input data. So this doesn't conform to the I2C specification. We can definitely use the I2C to PC to read this. There are two techniques which might work. So let's have a look at the first one. We'll switch over and have a quick look at the BL233 datasheet. Okay, normally we don't have this bidirectional read and write with I2C. But in SPI we do have the situation where we are writing data out and attempting to read the data in at the same time that we're writing it out. So we've got a special control bit in the control register that enables this. So by writing the control register and setting the bit F control emit write result, the BL233 chip will write the data out to the bus, and at the same time that it clocks the data bits out, it will clock the value on the data pin back into the BL233. At the end of the write, it will then return the data from the bus. I'm not sure whether this will in fact operate in I2C mode, but it appears to. So let's go and have a quick look at the status register. So here's the bit in the control register, emit write result. Alright, let's have a look and see what happens. Unfortunately I don't have one of these chips to try, so we'll just have to have a quick look on real term and see what happens. At the moment I've got a PCF8574 hooked up as usual, and I'm going to simulate the write operation to the or the write and read operation to the AS5011 by writing out F0, and we'll say that that's the register address in the AS5011, and then writing out the value FF. If data is asserted on the I2C bus by the chip, then it will read back different data. So this value is all ones, the I2C bus being an open drain bus. The slave can pull down the values, and so if there's any data returned by the chip, it will be returned at a lower value. Alright, so let's just write with a conventional I2C write. So this has the usual commands: start command, address 40, writes out F0, FF, and then a stop. We've got some commands in the latest version. Notice I'm using version 69, version 68 is on the website. That is on the I2C chip website. So we've got a control register setting here, and we can set emit write result. Notice it's written out this command J48 to set the control register. Now we'll try repeating our write operations. Pop in a new line there. Okay, as we've written the data out, it has echoed back the write results. So this obviously is the 40 that we wrote out, this is the register address that we wrote out, and since the chip that I've got on the bus doesn't assert any data on it, we simply read back FF. But this byte would have been the read byte in the AS5011. So that's the easy way to do it.